talking variation functions, I would love you to be able to solve problems with direct, inverse, joint, and a combination of all those variations. Now, direct variation is something you're probably very familiar with. It's very similar to like slope. So direct variation is a relationship between two variables, x and y, that can be written in the form of y equals kx, where k is not 0. It stands for the constant of variation. Oh, fine. So let's try one out. Given y varies directly as x, and y equals 14 when x equals 3.5, write and graph the direct variation function. Y equals kx. So we drop in these variables here. It says that y is 14 equals k times x. It said it was 3.5. So if we're solving for k, you got to get rid of that 3.5. So we'll divide it on both sides. And 14 divided by 3.5 is 4. So 4 is your k. Now if we drop that back into the original formula, y equals kx, we'll have y equals 4x. Now if you were to graph that, your y-intercept is 0, right? And you're going up 4 and to the right 1. 1, 2, 3, 4 over 1. So your graph might look something like that. A little something like that. Given y varies directly as x, and y equals 6.5 when x is 13, write and graph the direct variation function. We're starting with y equals kx, no big deal. No big deal at all. It says y is 6.5 when x is 13. So we'll divide that 13. And that comes out to 1/2, because 6.5 is half of 13. 1/2 equals k. So if we were to write that back in the orig, y equals kx, it would say y equals 1/2 x. Which that has a y-intercept of 0. And the slope is 1 over 2. So you go up 1, to the right 2. There's your next point. It's almost too much fun.